Hi, boys and girls. Happy Monday morning. Welcome to week 2 of our online learning. We're going to start with Module 14 this week, and Lesson 1 is entitled Relate Fractions and Area. So if you turn your books to page 385, you can follow along with the lesson. Our I Can objective reads, I can use a fraction to show that equal parts of a whole shape have the same area. If we decompose that I can objective, we can see that we've worked on a lot of these skills. We're familiar with fractions and equal parts, and we've definitely learned a lot about area. So let's see how we can put these things together and have them relate to equal parts of a whole shape. And to help us with today's lesson, I've brought back Tyler. Tyler, can you say hi?
Hi, I'm happy to be back and help you with this lesson.
And I'm sure that Tyler is going to join us for many lessons in the future. So please turn to page 385 so that you can follow along with us. Let's take a look at Build Understanding. Number 1, Davida draws lines to divide shapes A, B, and C. Which shapes are divided into equal areas? How can you show which shapes are divided into equal areas? Well, I see my 3 shapes, A, B, and C, and I notice that they're all trapezoids, and they're all the same size. I also notice that one of the trapezoids is broken up into 3 parts, and the other 2 are broken up into 2 parts. I want to look at each trapezoid separately, and I want to compare the area or the space inside of each of their parts and see if they're the same. Tyler, is that something you can help me out with?
Yes, I can. So I drew the trapezoids with markings on a blank piece of paper. Then I cut the markings into pieces, and then I organized the pieces of the trapezoids to compare them.
And what did you find out?
For trapezoid A, I found out that all the triangles have the same area.
And how do you know they have the same area?
Because they're all the same size.
Awesome. So same area for each of the 3 parts for trapezoid A. What about trapezoid B?
For trapezoid B, I compared them, but one was bigger than the other, so they were not the same area.
Okay, and what about trapezoid C?
For trapezoid C, I flipped one over, and then I compared it, and they were the same size, so they are the same area.
Good. Those 2 shapes do have the same amount of space on the inside, so they have the same area. So out of the 3 shapes, Tyler, which ones are broken up into parts that are the same size or have the same area?
Shape A and shape C.
Shape A and shape C. I agree with you. Let's take a look at number 2. Number 2, Edgar draws lines to divide circles A and circle B. Each circle is the same size. A, are the parts of circle A equal or unequal? And how do you know?
Well, for circle A, they all are equal because they're the same size.
Okay, so these 4 parts on circle A are in fact equal.
It kind of reminds me of a clock, maybe. All the quarters.
Oh, that's a good way of looking at it. It does remind me of a clock. The 12, the 3, the 6, and the 9. So you have 4 equal parts in that circle. So they do have the same area. So they're equal. So the parts of circle A are equal because they're the same size. Awesome. Well, let's take a look at B. Are the parts of circle B equal or unequal? Explain.
Well, for circle B, I think they're unequal because they're different sizes. The top and bottom are smaller than the middle two.
Awesome. I agree with you. So circle B, the parts of circle B are unequal because the parts are different sizes. Okay, and yes, the top and the bottom part are in fact smaller than the two middle parts. Great job. Number 3, Reina divides a rectangle into parts. A, are the parts of the rectangle the same shape? Explain how you know. Well, let's take a look. I have my figure here on the right side of the screen. Okay, and that is my whole rectangle. But my whole rectangle is divided into different parts. So question A asks, are the parts of the rectangle the same shape? Well, if I take a look at it, I have one shape that looks like a long rectangle. I have another shape that looks like a sideways L. And then I have two other shapes that look very different. So no, they're not the same shape. And how do I know? Well, I have one that's a rectangle. The yellow one has 1, 2, 3, 4, 5, 6 sides, so that's a hexagon. 1, 2, 3, 4, 5, 6, 7, 8 sides, that's an octagon. So even without counting the last one, I have a shape that has 4 sides, a shape that has 6 sides, and a shape that has 8 sides. So they're definitely not the same shape. And let me erase some of this. Okay. And now let's take a look at B. Do the parts of the rectangle have the same area? How do you know? Well, before I find the area of each of those parts, let me review what area is. Now, I know that area is the measurement inside of a shape, and we use square units. We use square units to measure. And the way we do that is we line up those square units and we cover the shape completely without them overlapping, kind of like the tiles on a floor. Okay? And when we measure area, we're really counting how many of those squares would cover up the shape. So let's take a look. We'll start with the yellow shape and let's count how many square units is in that shape. Well, this one has 1, 2, 3, 4, 5, 6 square units. I'm going to look at my green shape. It has 1, 2, 3, 4, 5, 6 square units also. And let's look at the pink. 1, 2, 3, 4, 5, 6. And then the orange one. 1, 2, 3, 4, 5, 6. So I think that all of my parts in my rectangle have the same area. They each have 6 square units as their area measurement. So do all the parts of the rectangle have the same area? Yes, and how do we know? Well, they all measure 6 square units. So if we're talking about fractions, would this be a good way to show fractions of a whole? I think so. Even though the shapes are different, the amount of space inside is the same. And remember, with fractions, we want the same amount of space for each part, or the same amount for each part. So they each have an amount of 6 square units. So this would work well with breaking something up into fractions. So what fraction of the total area is shaded yellow? How do you know? Well, a few different ways that we can do this. We know that the yellow shape has 6 square units. The green shape has 6 square units. The red shape has 6 square units. And the orange shape has 6 square units. So I know that my total amount of units in the area for that rectangle would be 6, 12, 18, 24 square units. Yeah, 24. And my yellow part is 6 of those square units. So I can use the fraction 6/24. But I also want to show you another way. Instead of looking at the individual units, I know that each of my parts have the same area, and I know that this shape is made up of 4 equal parts: part 1, part 2, part 3, and part 4. So I know that my yellow part is 1 part out of the 4. So I can also write the fraction 1/4. It's your turn, boys and girls. You're going to complete check understanding and on your own. So I want you to pause the video here, complete that independently, and when you're done, come back to us so we can go over the problems. Hi, welcome back. Let's start with number 1. Circle the shape that is divided into parts with equal areas. Tyler, I'm going to hand it over to you.
Well, I would circle the first one because it has 6 equal parts. For the second one, it doesn't some parts are bigger than others, as you can see.
Okay, good. And number 2, for the rectangle shown, do both parts of this rectangle have the same shape? Explain how you know.
No, they don't, even though they have the same amount of sides. If you cut them, they won't really go on top of each other.
Okay. Do you notice anything else about their size?
But they have the same area of square units as 10.
Good. So no, they're not the same shape, but they do have the same area. So even though those two shapes look a little different when they're cut out and placed on top of each other, they do both have the same amount of area. They have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 square units. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 square units. So they each have measure 10 square units. Good job. On your own, number 3, Garrick says that the shaded area 1/3 is of the whole because it is one of 3 parts that all have the same shape. Aiden says that the shaded area is not 1/3 of the whole because the 3 parts do not all have the same area. Which student's reasoning is correct? Explain. Well, if I take a look at my trapezoid, I do notice that it's broken up into 3 parts. But if I compare my top part and my bottom part, I notice that my top part is a lot smaller than my bottom part. And I know that when I'm working with fractions, the parts have to be equal or measure the same amount of area. So I agree with Aiden because the parts do not have the same area. So we can't be talking about fractions. Number 4, cross out any shapes that have parts with unequal areas. Let's take a look at the first one. The first one is a hexagon. And if I use that line as my line of symmetry, and I imagine that I'm folding the shape over onto itself, I'm going to notice that those two parts are equal. The second one, the circle, it reminds me of a pizza, and I see that there are 8 equal parts in that circle. The third one, the triangle, I would have to cross off because I noticed that these two parts on the outside, on the left and the right, are a lot smaller than the two inside parts. And the last one, my blue trapezoid. I can see that my blue trapezoid has 3 equal parts. And if I were to flip this middle triangle up, I would get a triangle that looks very similar or the same as the other 2 triangles. Now, Tyler, you think you can help me out with number 5 and 6?
Yep.
Oh no, it looks like our Minecraft fox is hiding the picture. It's a wolf? Yes. Sorry about that. Number 5. Are the parts of the rectangle equal in area? How do you know?
Well, I know because there are 4 square units in each different color.
Okay, so let's count them.
1, 2, 3, 4.
The yellow.
1, 2, 3, 4.
And the blue.
1, 2, 3, 4.
Okay, so how would you answer that? Are the parts of the rectangle equal in area? How do you know?
Yes, they are.
And why?
Because each different part has 4 square units.
Good, so yes, because each part measures 4 units squared or square units. And number 6, what fraction of the rectangle is shaded blue?
Well, 1/3 of the fraction is shaded blue.
Okay, and how did you come up with that?
Well, I came up with it because the denominator would be 3 because there are 3 different parts. And the numerator would be 1 because one part of the 3 is blue.
Okay, good. So you're looking at this as 3 parts like this. And since we know that they all have the same area, they're all the same size. So one part is blue, and the 3 refers to the entire shape. So 1/3 is blue. Great job.
Oh my gosh. I just looked at the background and got a little idea. These all look like Minecraft squares. Oh, I think we can make a little problem out of this.
That's a good one, but these colors are too close together, Tyler. That would be really hard to find fractional parts for those colors, but good thinking. So like Tyler said, boys and girls, Minecraft is an excellent place to see math. There is a lot of fractions and area and volume. And Minecraft, most of their shapes are built on with squares or with cubes. So you can solve a lot of problems using Minecraft characters and backgrounds. To wrap up today's lesson, let's think about what we learned. We were definitely working with fractions and with area. And the way we did that, boys and girls, was to compare the area. Before we can use fractions to name a part of a shape, we need to make sure that those parts are the same size or have the same area. Today's homework, we are not doing an AirPod activity, so today's homework is in your homework book on page 147 and 148. After you complete that, please email me a picture of your work, or you can upload it to Class Dojo. And boys and girls, remember my email is sgomes@nps.k12.nj.us. I miss you all, and you can always send me an email just to say hi. See you tomorrow.